So this is the same thing as what my previous video was, but now we're just going to have just something slightly different, just in case you end up with something more difficult than what you were experiencing in class. And I did the same steps as I did before. I found that I had a solution at -1, and it crosses, so I know it only hits that once. And then I also have a solution at +1, and this is the one where it's approaching, it's decreasing down to 1, but it's all increasing away from 1 as well, and so I know that I have multiplicity right here. But the issue is, again, I have an exponent, a degree of 5, and I only have 3 solutions, so that means there's 2 imaginary solutions out there that I need to find. And so I'm going to do the synthetic division and hope that I can find that pretty quickly. So bring down my coefficients. That's going to give me +1. This will give me -1. -4, +4. This will give me 9, which is -9, which is -10. -1 times -10 gives me +10, which gives me a +4. And then my -4. So that cancels out. I'll do 1, and I have to do this one twice in a row because it has multiplicity. Carry that down. Give me 1, -3, -3, and 6, 6, and -4, and finally -4. And we'll do it one more time. And it worked out. And so now we have this thing going on. And so as I did in my previous videos, again, we started off with x to the 5th. Every time you divide, you end up with one last power. And so now we're at this x squared, and we just go down the list. The next one would be x, and then the last number is always going to be your constant. And so really this is going to be x squared minus 2x plus 4. Now, I could try to factor this with my x method, my -2 and my 4, and list my factors of 4, which is 1 and 4, 2 and 2. But the problem is, if I have a positive, if I do this, then none of these options actually give me a -2. And because of that, I can't actually factor it with this method. But I do know a foolproof method. That foolproof method is everybody's favorite, the quadratic formula. So that is, for those of you who don't remember, it's -b plus or minus the square root of b squared minus 4ac, all of that over 2a. So my a in this one is 1, my b is -2, and my c is 4. And I can plug this in and get my equation. So we wrote the formula, and I went ahead and plugged everything in to the quadratic formula, and now I can start simplifying. This will give me +2 plus or negative the square root of 4 minus 16, all of that over 2. And if I keep going, that'll give me 2 plus or minus square root of 12 over 2. Now before we start, -12. Before we started this, I always like to review the radicals section so that we can easily deal with our square root of -12 and we're not confused by it. And so this is actually can be reduced into 2 plus or minus 2i times the square root of 3. Remember, if you have a negative, it can come out and turn into I. And then if you rationalize square root of 12, that'll give us 2 times the square root of 3. And so now that we have this, we can go ahead and reduce all these 2's, and it'll end up being 1 plus or minus 1i, or just I, times the square root of 3. And so now I have the 2 pieces that I was missing earlier. I said I had 3 at the beginning for my picture, but I was missing 2 because I have a degree of 5, and I found those 2 right there with 1 plus and minus I times square root of 3. And so for the final step, we're just going to write everything. We're going to list everything. It'll be x equals -1, 1, and 1, because we had multiplicity on that positive, comma, and I'm going to write these separately as well. 1 plus the square root of 3, and, forgot that I. 1 minus the I times square root of 3. And so this becomes our answer.